The students heard a reporter saying that strong earthquakes will cause large destructive ocean waves called tsunamis, while weaker ones will not. They decide to check this. They draw two histograms back to back, one showing the magnitudes of the earthquakes that caused tsunamis and the other showing the magnitudes of those that did not. They use all of the suitable data from the 20th century that were recorded in this particular database. Comment on the reporter's statement, using information from the diagram to support your answer and suggest a more accurate statement. We can see that of the earthquakes that cause tsunamis, that's earthquakes shown on this side, as we increase the magnitude, the number of earthquakes that causes tsunamis increases. So you can see that this distribution is skewed to the top. It's actually skewed downwards, if you like, or skewed to the left if we were to look at this, rotate this picture through 90 degrees. So you can see that the stronger the earthquake, the more likely it is to cause a tsunami. But you can see over here, these are the earthquakes that do not cause tsunamis. We can see that there are quite a lot of strong earthquakes that do not cause them. For example, we could look at earthquakes whose magnitudes range from 7.5 to 8. This range here, 7.5 to 8. We see that there's about, what's this, 120, 130, 120, 140. There's about 140 of those earthquakes that cause a tsunami, but we also see quite a lot that do not cause a tsunami. We read off here, there's also about 140 that do not cause a tsunami. So there's a lot of strong earthquakes that do not cause tsunamis. So this statement here that strong earthquakes will cause tsunamis is too deterministic. A strong earthquake does not necessarily cause tsunamis, but strong earthquakes are more likely to cause tsunamis than weaker ones. Because if we look at a weaker earthquake, let's say an earthquake whose magnitude ranges from 5 to 5.5, you can see that very few of those earthquakes, relatively speaking, cause earthquakes. That's this region here, compared to the number of earthquakes of this magnitude from 5 to 5.5 that don't cause tsunamis. A lot more. So you can see that this distribution here is somewhat skewed in the other direction, somewhat skewed to the right, to the left. If we were to display this on a diagram, the weaker values are actually down here, the larger magnitudes are up here. So it's skewed somewhat. Well, it's actually skewed in this direction here, slightly skewed, although it's also quite symmetrical. But you can see that we have far many more weaker earthquakes that do not cause tsunamis. So you can see that these bars here are much longer than the bars on the corresponding side. By taking suitable readings from the diagram, estimate the probability that an earthquake of magnitude between 6.5 and 7 will cause a tsunami. So let's look at that magnitude range. It's here. So what we want to look at is the frequency or counts of earthquakes in that range that do cause a tsunami and that do not cause a tsunami. Let's look at the number that do cause a tsunami. So we want the length of this bar here. So if we project down here, we get down to this value here. Each of these squares represents 20 earthquakes. So if we're looking at this value here, it's between 100 and 120. This is 120. And it's closer to 100, so we might say it's about 105. The official answer is actually 103, so I'll just use this answer here. 105 is good enough too, as long as you're closer to 100 than to 120. Now we want the number of earthquakes in this range, 6.5 to 7, that did cause or did not cause tsunamis. So that's the length of this bar here. So if we project down here, well, this reading here is 100, 120, 140. This would be 160. So this value is just a bit to the left of it, but it's close to 160, so it might be 157. The official answer is 156, so I'll go with that. So that's the length of this bar here. We just project it down to here. So to calculate that the probability that such an earthquake will cause a tsunami, what we want to do is look at the total number of earthquakes in that range from 6.5 to 7. That's just got by adding the lengths of the two bars together. That's 103 plus 156, which is actually 259. And we want to get the proportion of that number of earthquakes that cause tsunamis. So we want to put the number of earthquakes, 103, that cause tsunamis in that range out of the total number of earthquakes in that range. So we get a probability of 0.4, or we could say that, if you like, you could say that 40% of earthquakes in the range 6.5 to 7 will cause a tsunami. Okay, so we're trying to make predictions based on this data. So this is just an estimate of the probability. We can't know what's going to happen in the future. We're just using our data here to say that since 40% of earthquakes that have magnitudes between 6.5 and 7 cause tsunamis, we will say that the probability is 40% or 0.4 that an earthquake of such a range of magnitudes will cause a tsunami in the future. Consider the next 6 earthquakes of magnitude at least 7.5. So let's go up here. So we're interested in earthquakes of magnitude at least 7.5. So that's everything above this line here. So we'll be interested in rectangles above that line. Find an estimate for the probability that at least 4 of them will cause a tsunami, assuming that these 6 events are independent of each other. Now we're going to be dealing with a binomial distribution here. But first of all, what I want to do is get the probability that earthquakes of magnitude at least 7.5 will cause a tsunami. So we want that probability, so that'll be the little p of our binomial distribution. So what we want to do is get the total number of earthquakes whose magnitude is greater than 7.5. So that's the areas of all of these rectangles, or the lengths will give us the areas, or the lengths will give us the frequencies. So this first one here has a length of 140. What about this one here? That's this value here, 20, 40. This is 60. So we have 140 here. We have 60 here. What about this one here? Well, this is close to 0. It looks like 5. Remember, this value here is 20, so this value is about 5. Actually, I'll give the official answers. For this, it's actually 142. It's a little bit more than 140, but 142 is the official answer, although 140 is probably good enough. It's hard to read this. This length here is actually 60. That's the official value. That's what I had as well. And this one here, the official value for this one here is 7. Now on the other side, we have number of earthquakes that do not cause tsunamis, whose magnitude is greater than 7.5. So this one here, the official value is 7. For this one here, it's 36. Actually, it's between 20 and 40, but closer to 40, much closer to 40. So 36 is the official value. And this one here is actually given as 139, but I mean, if you write down 140, it's very close to 140, but I'll just give the official value, which is 139. So I've circled all of these here, so we have to add up those. So we just add up all those numbers to get the total number of earthquakes whose magnitude is greater than 7.5. That's just the lengths of these 6 bars. And out of that total, we want to take the number of such earthquakes that will cause a tsunami. So that's these three here, the ones in light shading. That's 142 plus 60 plus 8. Actually, I had that as a 7, but the official value is 8 for this here, for this bar. So that's how we calculate P for the binomial distribution. If you calculate that, you get 0.54 approximately. Now we're interested in a sample of 6 earthquakes. So that's our little n in the binomial distribution. And these 6 earthquakes have magnitudes of at least 7.5. So some of these earthquakes will cause tsunamis, some will not. The probability that one of these 6 will cause a tsunami is 0.54. The probability that it will not cause a tsunami is 1 minus p. So that would be 1 minus 0.54. That's 0.46. We want to find an estimate for the probability that at least 4 of these 6 earthquakes will cause a tsunami. So what does at least 4 mean? It means the probability that 4 of them will cause a tsunami, or the probability that 5 of them will cause a tsunami, or the probability that all 6 of them will cause a tsunami. So these are the probabilities we have to calculate. We have to add them together. So we're dealing with an OR situation and probability. So that means we've to consider more than one outcome. So we're adding the probabilities to get a value which is greater than each of these probabilities individually. So adding them is the only thing that makes sense. So I'm going to let x equal the number of earthquakes that cause a tsunami. So that's the number of earthquakes out of the 6 earthquakes. So our formula for the binomial distribution is that if the probability that x equals r, where r is some number, r is some number from 0 to 6 actually, 0 to n, equals ncr times p to the power of r times 1 minus p to the power of n minus r. So that's the binomial distribution, which I've explained in more detail in other videos. I won't explain it here again. I'll just run through the calculations. So we're interested in probability x equals 4, or I'll just write down p4. That's this probability here. So it's n, which is 6, choose 4, r is 4, times p, which is 0.54, to the power of r, which is 4, times 1 minus p, which is 0.46, to the power of n minus r, that's 6 minus 4, which is 2. P5 is 6c5, r is 5 now, we just put 5 in for r, and we get 0.46 to the power 1. So this should make sense. P5 is the probability that 5 of our 6 earthquakes, exactly 5, cause a tsunami. So since we're dealing with independent events, we have the probability P, which is 0.54, that an earthquake does cause a tsunami, to the power of 5, because we have 5 independent events, and we want the 6th one to not cause a tsunami. That would be just 0.46 to the power 1, or just 0.46. And we have 6 C5 ways that can happen in. Okay, so that should kind of make sense, but this is explained in more detail in another video. So what we've got to do here is just add these probabilities together. So we just want to add all of these together. And we get the probability that at least 4 earthquakes cause a tsunami is 0.421. At least 4 earthquakes that have magnitudes greater than 7.5.